This is lovely Laundry, Lakehurst, New Jersey. We're now facing southernmost point of the building, which is where you want to put a solar system. The array that you're looking at is 175 watt per panel, ballasted, rapid rack system at 10.5 kilowatt production. The system is going to be connected through an array of 4 separate strings of 15 modules. The 15 modules will be combined through a combiner box, through the conduit, and then fished or run down, home run to 2 inverters. The 2 inverters are Sunny Boy 5000. Each one's potential is 5 kW. The 5 kW is distributed with a 1.25 ratio, which will give it to where you can basically, each one you can be about 5.5, which puts us within the 10.5 kilowatt max load production in which we're doing. The project began March of '09. After about 200 hours solid of rebate paperwork, solometric sun shade data, working with different vendors to find out which vendors, would satisfy the project. Close to 9 months, 10 months later, here we are. This is a rapid rack system. Each rapid rack system has in the north end and the south end has an anchor, and the sole purpose of those racks on the ends are only going to be for weighing down and balancing out the array, which was configured based on the surface area of the 175 per watt, 4 strings, which is a total of 60 modules. This system is called a ballasted system. It's not going to be penetrated into the ground. As you see here, these are what they call ballast, but really what they are is they're just regular old cylinder blocks. They're weight specific. An engineer calculated the exact amount of weight which would be needed on each joist in configuration with the rafters of the building. The initial formula for a job of this size, you start out with sizing the system. Once we found out we had a 10.5 kilowatt system that we were going to produce, we first had to find out the one, the only, the SMA. Yes, that is all we use because they had been out the longest and they're the most cost feasible for the price. We don't want any problems, and SMA delivers every time. In addition, once we were able to figure out what inverter company we would use, we then had to figure out what size system or inverter that we would use. And we could have gone with a few different ones, but what we did is we went with 2 5 kilowatt inverters, because what we wanted to do is we wanted to finish out each inverter so that they work better. For example, if we went with a 7 and a 7, we would have had approximately 4 kilowatts that weren't being utilized, and the system runs more efficient with that. Once we figured out what that would be with the inverter sizing, we then had to figure out what panel we would use, and we went through a few different panels, and we ended up going with the 175 watt Yingli. Yingli is pretty much SMA in size, reputable in size, and these rebates are based on a commitment to a certain amount of time for a warranty. The warranty is meaningless unless the company is going to be around 25 years from now. And there's so many companies that have come and gone due to fraud, unlisted through UL, which is required, etc. Yingli in the next quarter is projected to drop the solar prices by another $1.25. That's what today's solar energy is about. Finding the best bang for the buck with the best quality, and there has to be the best quality every single time. This is a rapid rack system, and what we did is we figured on our commercial jobs, what we're gonna do is we're gonna go with a ballasted system because we don't want to penetrate the roof when we have the ability to use science and innovative engineering to be able to prevent, unnecessary and inevitable damage caused by penetration of the roof over time. There will be leaks, and that's why we don't penetrate the roof. Like I said, there's 4 separate strings of 15 at a total of 60, 175 modules. And this ballasted system here, we have a total of 10 anchors on the northern end, and we have a total of 60 frames. The 60 frames is what holds at a tilt of 10 degrees. 10 degrees is required in this system in order to produce the amount of kilowatts in which we have made a commitment to on the PV watts diagram. The PV watts diagram, the way that works is it's a production model, and it uses the azimuth, the tilt, as well as the orientation of the array facing true south. Again, there's a total of 60. Each module has a male and a female wire. This here is in what they call short circuit. The reason why the negative and the positive are together is because without that together, you have a live, and if I can remember, Mr. Nick, project director / marketing department, what was the exact amps that you read on that, sir? 28. And what was the no-no that we did find that we'll make sure that it doesn't happen again? Which means it wasn't in short-circuited. And we basically took the 2 wires on one of them, and we had seen that it was at 28 amps. 28 amps is about 22 short of my hot tub of 50. And that hot tub, without a doubt, would definitely give you a nice blast for your money. Once this array is configured, there's a lot of behind-the-scenes things that have gone on. The rebate program, sizing, and in addition to that, we went through permitting, which required an engineer stamp. This went through 3 separate levels of engineers and designers, double checking one another, including all the manufacturers who sized it on their own also. Rapid rack, the metal rack here, the modules sized, the inverters sized, the distributor who gave us all of this system and combined it in a package sized it. And then we had an outside agency, the outside agency who actually deals with approvals, their engineering staff. They basically gave us a sizing as well as a overall analysis of what they thought the feasibility was. So, and then on the last part, we had an engineer as well as a electrical engineer and the project general contractor who is, producing the excellent job that we have so far. My name's Joe Rulo, and I'm the project director and developer from Seed. This is a typical job that we start out with. This has been about 9 months to 10 months, but usually the jobs will take anywhere between 2 and 3 years before you will even get to this part, because there's just so much different obstacles that you have to do, as well as information, testing, and feasibility studies. This building is going to power 5 horsepower dryers and washing machines. The washing machines are electric. They're 5 horsepower. In addition, there's dozens of washing machines and dryers in the front end that this good old-fashioned American commercial laundromat is satisfying the needs of probably close to 1,000 residents and different businesses a year. This array in itself is going to save over 9,000 trees over its 25 years.